I mean, yes, but eventually. If all right, if x is cosine t, so just rip that paper out of your notebook, erase it from your brain. All right, we're asked to find the second derivative of y with respect to x. So I'm just going to take derivatives. I should have just went with what I always tell y'all to do, just take a derivative. Derivative here would be negative sine t, and since I'm doing it with respect to t, I don't have to follow with a chain. Dy dt is negative sine 2t times 2, so negative 2 sine 2t. All right, so dy, so now if I do dy dt times dt dx, it should leave me with dy dx, right? So I'm going to flip this one. So I'm going to say this is negative 2 sine of 2t divided by negative sine t. There's your trig identity, the double angle, right? What is that? Sine of 2 theta is what? 2 sine theta cosine. But it already had a 2 out there, so it needs another one. I'm starting to see where that 4 is going to come from. That's a trig identity. Different sheet. The trig identity sheet, the one that is terrible. It's a double angle identity. The sine of 2 theta is equal to 2 sine theta cosine theta. All right, sine theta is negative, so I end up with 4 cosine t. I thought y'all said the answer was negative 4. So now if I do the second derivative here, how's it be? Oh, because I'm going with respect to x, that's right. So the second derivative with respect to x, negative 4 sine t say again. Did I find dt dx? Yes. What's dt dx? 1 over, that's right. Great day. So I had to use that dt dx from up here. I had to flip that dx dt over. And that gives me 4. That was gross. I think I would cry if I saw that on the test. And I would have never guessed that was not. Well, between all of us, I believe you. Let's see. If f of x equals 2x cubed minus 6x. Is that the one you're talking about? At what point on the interval between 0 and square root of 3 is the tangent to the curve parallel to the secant line on the interval? So what does that mean? Same slope. The slopes have got to be the same. So I need two different things. I need the slope of the secant from 0 to square root of 3, and I need the slope of the tan, or I need to see where the slope of the tan equals that. So how do I find the slope of the secant line on a certain interval? What's a secant line? It goes through the graph 2 points, right? That's all it means. So it's just AROC. It's just the slope between those 2 points. So what I need is f of 0 and f of square root of 3. Gross again. So if I want to do slope for these 2 points, I'm going to do this. So 2, and this is actually going to be 6 square root of 3. No. I think it is. This is non-calculator, right? Square root of 3, 3 times. It's making me question myself. Is 3 square root of 3. I got the 2 out there. 6 square root of 3. 6 is 0, right? Gosh, that's what I was thinking, but. So I got this. The secant line slope is 0 over. It doesn't even matter as long as it's not 0, and it's not because square root of 3 minus 0 is just 3. So what I'm looking for is where is my tan line, if ever? Where is the where's it horizontal? Or where is the slope? Where's the derivative equal to 0 is essentially what we're looking for. So I need to find, for this, I need the derivative. 6x squared minus 6. So the question is, when does this equal this? So when is 6x squared minus 6 equal to 0? 6x squared equals 6. X squared equals 1. So it's when x equals plus or minus 1. I do have a range here of numbers that I'm looking between 0 and square root of 3. So it only happens one time, and that's at x equals 1. So I would choose A. Is that the answer? I hope so too, because I'll cry. No, I'm just quit my job. Okay. Yes. Yes. Is it still locked? Adam, what was your question, or did you say never mind? Okay. Oh, I wrote something down to give y'all a shortcut for that. If I need the derivative of an inverse at a point, then I do 1 over the inverse of, no, the derivative of the inverse at that point. I don't know why I struggle remembering this, but I have always struggled to remember this little formula. But it will really come in handy. So with 1 like 61, they're telling you that y equals f of x, which equals 2x cubed minus 3x, It says that h of x is the inverse function of f. So essentially that's what they're saying, right? H of x is the inverse. And it asks you for h prime of 1, so the derivative of 1. So really what they're asking you for is the inverse of f, the derivative of that at 1. So I'm going to use this little shortcut. So let's see. Let's see what I need. And I'm assuming this is the way that they went about it, because this is the way they love to do it. Yeah. They said derivative of the inverse. Okay, what do I know? I know the derivative of f is 6x squared minus 3. The slope of the inverse of a function is the reciprocal of the slope of the function. Okay, so what I mean by that, let me just start it over. F of x is 2x cubed minus 3x. H of x is the inverse, and they want me to find the derivative of the inverse, right? So if I can find the slope of the function at that point, I can just reciprocate it to find the slope of the inverse. That's all it is. So the derivative, of course, would be 6x squared minus 3. So the slope at the point, what was it? -1 would be 6 minus 3, which would be 3. And if I, it'd be yes, it's just flipping the answer. But This is actually positive 1. Because you're plugging in the y value because of the inverse, right? Does that make sense? So, okay, so which other one? 62 does the same thing? 60. Oh, that's a composite. Let me do 62 first. Let's make sure this comes back, that what I'm saying works. Okay, f of x, x cubed minus 3x squared plus 8x plus 5. Again, I want g prime of 5, but I want g of x is the inverse of it. I'm going to do f of 5 first, and that's going to give me 125 minus 75 plus 40 plus 5. Well, what we get here, we're going to plug into the derivative. And then we're going to reciprocate it. 125 minus 75 would be 50. Is that right? It's 100. Five, right? Where does this equal 5? Didn't work. The math didn't math. Okay, so this one, if we get, this is the way I was trying to do the other one, but it wasn't working out because I was like, there's no way without a calculator and without them giving you, the ones that I've seen on multiple choice, they give you, they say if f of x is this and f prime of x is this, and they'll give you enough information to essentially plug in that little shortcut formula that I gave you. And normally that's all it is a plug and go kind of formula. For this one, because I didn't have a lot of information, here's what I'm thinking. I need to know where this is equal to 5, right? And this is an easy one to look at and go, okay, well, what would you have to plug in for x to get that to equal 5? 0, right? That's the only way because this little y-intercept down here. So really what I'm looking at is when x is 0. Because remember, inverses mean I'm switching x and y, right? So now what happens if I plug back in with my 0, right? Because I want to do, it's asking me for the inverse derivative at 5. So the derivative here, of course, 3x squared minus 6x plus 8. So now if I put that 0 in, I get 8, and now flip it. Is the answer 1/8? Is that what they got? Find the derivative at the y value of the function there and flip it. So, in other words, since it's saying a 5, so I'll go back to the original function. Where does the original function equal 5? Plug that into the derivative and flip it. Which is essentially what we should have done over here. We should have said, well, where does, and I think this is where you were saying it said by observation. Since -1, where does this equal -1? That's what I was trying to do with the problem initially whenever I said it, and I went, wait, you can't really solve that. They said by observation. I guess looking at it, knowing that you could plug in a 1 here and get, because 2 minus 3 is -1. And so then we did f prime of 1 and flipped it. Stupid. All right, so you find where the original function, which is your f of x, equals this value. So where does it equal 5? Then you do f prime of whatever this is, and you flip. I've been zero help today. Alex, did you ask about 60? Because I can do that one. Whatever this x value is, right? X equals blah, and that's what you plug it, yeah. Right. $60. F of x is 1 over x squared. This looks like a chain rule problem. D of x is the square root of x. The derivative of f of g of x. So what I'm going to do is I'm going to do the derivative of f, and then I'm going to chain it here. So I might just come in here and go ahead and say, well, the derivative of f is, so you could do this as, you could make this an exponent and then chain it, or you could do the quotient property. I guess first, though, we could plug g in. It'll make it easier if we plug g in first. No, we got to do derivative first. Yes. Now I'm going to plug in the square root of x. And I'm going to multiply that by the derivative of g. I got c. Yep. which would be A. I give up. Dropping my pen today. No, don't be sorry. There's no reason I cannot work every single one of these. My brain is not functioning. Are you talking about number one? Okay, so they're all using that table. You see the table? You sure? Okay. I'm not real sure why those are calculator problems when given a table. Tables are rarely really weird. Of 4 cubic feet per minute. So I'm gonna call that a dVdt because that's the volume's changing at that rate. This at the rate in square feet per minute at which the surface area is increasing from the volume. So this is what I have. They're wanting me to. I need to find the rate that the area is changing. And I also, when volume equals 32 pi over 3 cubic feet. Well, I need to know the area and volume of what would that be, a sphere? 4/3 pi r cubed. Is that right? Is that how you do it? Is that right? Did you look it up? Or are you just trusting me? Don't trust me. Not with anything like that. I'm pretty sure that's right. They give you these equations at the beginning of the exam. 4/3 pi r cubed. All right, so volume is 4/3 pi r cubed. I know I've got some area stuff over here. So what's the surface area of a sphere? 4 pi r squared. Well, let's see. I could find, because here if I do, I know I need dA dt, right? So if I do the derivative here with respect to time, I'm going to have 8 pi r dr dt. So I'm missing, I'm going to need the radius and dr dt in order to figure this out. So I think that based on the information given here, I can probably find that, right? For one, if volume is 32 pi over 3, what's the radius? I'm going to multiply by 3 over 4 pi. Does that make sense? Still not enough information, so now I also need to find dr. So I've got my r is going to be 2, but I need dr dt. So to do that, I'm going to find the derivative of volume with respect to t. So dv dt is going to equal, I'm going to do 4/3 pi times 3r squared dr dt. And I'm going to plug in everything I know. I know dv dt. dv dt is 32 pi over 3. Nope, just kidding, I lied. 4. Thank you. These two cancel. So I've got 4 pi times, and I found my radius at this particular moment, which is 2, dr dt. This is on page 196, by the way. This is tonight's stuff, this week's stuff. 4 equals 16 pi dr dt. Divide by 16 pi, I get 1 over 4 pi is dr dt, and that's my very last piece of the puzzle that I needed for this little equation, and that's going to go here for dr dt. So now just plug everything in. So dAdt would be 8 pi, that radius is 2, dr dt is 1 over 4 pi. Pi's are going to cancel. I got 4. Oh, you took a while to answer, and I was getting scared because I actually like these, and I was going to say, if I can't even do a related rates, then that's bad. You good? You sure? Okay.